Hi, I'm Geir Sjurseth. I think officially I'm a customer engineer at Google. I work with Apogee. Inside of Apogee, we don't really have titles, but I typically refer to myself as a customer solution architect. And I'm going to be talking to you about Edge APIs and kind of what we mean by that, or what I mean by that, and versus mesh APIs. And before I start, I should say that the impetus behind this discussion is a conversation I had internally with my colleagues at Google a couple months ago. So we've put a lot of focus ourselves on the mesh, on microservices, and specifically on implementing microservices via mesh. And there's this growing worry and uncertainty among some of us that maybe APIs and the way we do APIs is commoditizing. So we're getting to a point where everybody's going to do this exactly the same way. And actually, that's great. I mean, that means the whole world can connect easier. But it does sort of mean that those of us who want to think of ourselves as kind of the brain trust behind how we do some of these things, our lives maybe are not going to be as interesting as we used to think that they were before. And furthermore, that it might have its own effects kind of on how we think of the ecosystem, right? So first question is, what is management at the edge, and what do we mean by this? And I think the first couple of slides here I'm going to show you are probably going to be pretty familiar to you guys, at least in terms of theme. So for a long time, when we've sold Apogee, we've talked about you've probably got a bunch of systems of record of some kind. Maybe you've got an ESB on top of that. But that wasn't a very engaging layer. So this was a way to do point-to-point connectivity. This is a way to solve problems where maybe you had stateful type of issues you needed to solve. But at the top, you had some kind of new emerging layer where you needed to adapt to mobile phone problems, you need to adapt to multiple different types of web applications. Perhaps you have a growing partner ecosystem that want in some way to get access in a meaningful and simple way to that bottom layer, right? And so there's a bunch of needs that are baked into that we need to address, security and persistence, and, analytics maybe most notably, so that we can understand that layer. And that speaks very strongly to an outside-in approach. So this is something that we call the digital value chain. It's absolutely core to the way we see the API world, that instead of looking at your backends, whatever that is, and I've got microservices written down there at the bottom because that's not legacy per se, but it is kind of an emerging way to do these pieces, that as opposed to thinking about how you expose them, that we focus rather on how they're going to be consumed. And if they're consumed in a meaningful way, then that user on the far left is using some kind of application that makes them happy. And that user, by the way, doesn't have to be somebody holding a mobile phone. It could be a business partner of yours that's integrated directly with your logistics system in terms of how you deliver pieces of actual goods from one end to another. And there's a life cycle around this. We speak very highly of designing your APIs before you turn around and develop them. And I'll over-index on that, or index extra hard on that, and say that additionally, I think of APIs, if you want to design them first, because that provides a contract, a meaningful contract where the provider and the consumer can meet each other, so that both parties at that point can go their own ways and start developing. And then later you secure them, publish them. These need to scale to some degree and in a way that makes sense for your organization. Because if you have a really explosive and popular Edge API, your backend systems might become overloaded, right? So it's something we need to think about. You want to monitor and analyze these because you want to some extent to realize which API initiatives have worked, which API initiatives have kind of been a disaster, which developers from your developer community are using your APIs kind of gainfully and in a meaningful way, and which of them are not quite as successful. And then hopefully you can monetize them, right? And monetizing APIs could mean through an actual commercial support in whatever API platform you're using, so you're taking money per API call. But it could mean just that you've realized this vision of thinking about your APIs as products. And I know you guys have probably heard this from multiple sessions, but this really is where you want to get to, right? We want the APIs themselves to become so mature that they have a business owner, a product owner that manages them, that treats them like products. And then you end up with this virtuous system that kind of can repeat itself. If all that works, and you've done all that, then the reason it's working is because back on that digital value chain, right in the middle there, was a developer. And that developer is consuming your APIs. And ultimately, that developer needs to be as empowered and engaged as possible to do something meaningful with those APIs as quickly and easily as possible. And so it creates a whole world that we're used to telling, and this is the story that we've told for a long time. And this is a story of technology, it's a story of process, and it's a story of people, right? People are core to all this. We heard earlier that people are developers as well. I think it's a very good point. And we want to keep those developers as engaged as human beings as possible so they don't leave us. But the last couple of years, the landscape has begun to change, right? So we've got this notion of microservices, and everybody's got a different definition, but for me, a microservice is not simply something that's small. A microservice should be also idempotently deployable, right? So every time I deploy it, I get the same result. It should own its own data. It should have a bounded context. And notably, it should have a contract, right? And that contract, for me, ideally, is some sort of API. You want some kind of governance on top of that, ideally governance with a lowercase g and not a capital G, right? So rather than forcing our developers to do something, we want them to feel empowered on their own to follow the rules as opposed to enforcing those rules. Cloud and service brokers are a big deal now, of course. Everything is moving in that direction to massively host things in the cloud as opposed to building out your own infrastructure to do that. And then DevOps, and I put DevOps there because I think if you had asked any of us what DevOps means 10 years ago, we wouldn't have known, because I don't think it was a firmly planted concept yet. 5 years ago, we would have said DevOps really is about breaking the walls between operations and developers, right? So that we want to automate in lieu of documenting, and we want to make that kind of transition between whoever's developing the software to whoever's hosting the software as seamless as possible. But in this world of changing landscapes, in my humble opinion, DevOps is now really about that role becoming the same thing. And that has never been more relevant than inside the mesh. Because if you're building a microservice that you're hosting on the mesh and you're following the rules that I gave you before, where it's idempotently deployable, it's small, it owns its own data and it owns its own contracts, then that developer is now uniquely enabled to do absolutely every piece of that puzzle. And that means kind of the roles and responsibilities of what APIs mean and how they work have kind of changed a bit because we're putting more and more power directly into the hands of the developer, him or herself. And so I think that the world of APIs at the edge is just simply not equal to the world of APIs at the mesh. Because to some extent, the world of APIs at the edge is about a big easy button so that you can find all these developers and they can start using them. And they hide this ugly, horrible complexity at the bottom. Sometimes we talk about putting makeup on a pig. Whereas a mesh is really about this massive interconnectability between all these different services. And so it's just a vastly different thing. Whereas Edge is trying to do mashups and specific formats for different pieces. You don't have those types of concerns at the mesh. You're so close to your code that it doesn't matter. Frankly, if you're developing microservices and you're deploying them inside a mesh, inside of something running, say, on a Kubernetes orchestrated containerized environment, you're both the client and the server at the same time. And that means that the types of needs in the world that you're addressing has to change to meet that. And I want to use this analogy, and it's not a perfect analogy, of bees and beekeepers. So if we think of these small services as containers in their own right, and we follow this bee analogy, then if we don't try to put any governance on top of this, then it's like trying to get honey or royal jelly or wax from bees in the wild. So doing that from bees in the wild sucks, and that's why we build we build these bee boxes instead to put them in, and we run apiaries. We've got happy beekeepers that can go up to that box, extract honey and royal jelly and wax by pulling out a drawer and simply dripping that off of there, putting it in a centrifuge and getting what they want. And that, to some extent, almost forms its own APIs. Right? But we have no idea about the complexity that's actually happening inside of that box. All we've done is we've provided a place for the bees to come and for them to live and for them to do their work, and then we're happy to get everything we want at the edge of it. But if we lift off the top of that and start looking inside, we'll see 50, 60, 70,000 little bees that are all working in concert to deliver the things that we really want from them. So they're communicating on their own. They're living in this box of separate devices that are split apart into different partitions so that we can easily extract the pieces we want. And that's great, but we don't really have any control of how any of those pieces are working. But what if we look closer at the bees themselves and we learn about the facts about how the bees work and we wonder how they communicate? Well, it turns out Bees communicate on their own by dancing. So they'll do some sort of dance to communicate when it's time to go fetch more royal jelly and feed it to whatever might be coming the new queen, or feeding it to the existing queen. When it's time to go harvest new honey, or where the best places are to go get new nectar. They do this with dancing, and it's good that we have that insight. And the only reason we have that insight is because we started moving them into boxes. And once we started moving them into boxes, we had a little more control. So as opposed to letting these microservices run in the wild, we put them in a type of boxed container that gave us the ability to keep track of them. But that's great, but we still don't have any way to control any more of them, right? But what if I want to build a better bee, right? I want to think of that bee itself as its own container, its own Docker image that's running a little bit of software. And I want an interface. I want a way to connect to that individual bee, upgrade its own software, and while I'm doing that, change the way they communicate. So now, as opposed to keeping track of a whole box of bees, I can pinpoint 10 of them. And I can take these 10 bees and send them off in a particular direction, and these 10 bees and send them off in another. Well, now I've got a way to coordinate the whole hive. I can add my own new features to that bee box, that hive itself, to create a sort of hive mind and an interface so that I can interface that hive mind from the outside. And by doing that, this can become its own self-managed piece, but a self-managed piece that I have direct analytical control over, right? So I can control these pieces. And then once I've done that, maybe I realize that there is still a value in the bees communicating amongst themselves. So I want these bee containers themselves to still form their own contracts. And I want to keep track of those contracts. And I want to version those contracts. And I want to keep track of when this group of bees is consuming the services of this other group of bees and when they're talking to each other. And that becomes an API. So now that I've got 50,000 containers running in this glob of a bee box, I've introduced a way to kind of keep track of it. And this is where Apogee and Google, and I think probably every one of our competitors, is focusing a lot of energy right now, is how do we address this world where people are walking away from doing APIs at the edge and embedding themselves directly inside this thing of unmanaged complexity. And I think to some extent, this is kind of like the difference between physics and biology, where physics is about understanding how very small interactions scale up at the universal levels. Biology is about managing that massive amount of complexity and understanding how it all works. And we see that same kind of move here when we start talking about how we move from APIs that we ostensibly are only looking at the edge, even though there's something happening on the back end, versus tons of microservices that are still deployed inside of some type of container that we want some sort of access to. And that means that inside this layer, that things are kind of a little different, right? So as opposed to a digital value chain, I want to argue that we have a sort of virtuous cycle. There are APIs that stand between microservices, and there are APIs that are used ostensibly externally as well, maybe even to manage the whole hive. And at the middle of all that is a mesh. And that what we want to get to the point of managing is not that we create individual APIs that we upload onto individual bees or upload inside of an individual container, but that we have a mesh concept, a hive mind, that can keep track not only of the individual containerized services, but of the contracts those services are running and where they're responsible for them. And this is exactly what we're trying to address with products like Istio. There are competitors, of course, things like Ambassador, and people can run these type of mesh infrastructures with Nginx. Linkerd is another option that's out there. But everyone's trying to address ultimately the same thing. And that means that this problem space of massive complexity and emerging management, I guess you could say, is rather than it being about technology and process control, it's really about analytics, rate controls, and security. Because I still want to know, if I deploy a service inside of a mesh, it's still important to me that I limit the use of that. Because there might be a notable backend behind it that I want to keep track of. I need to not overpower whatever that backend is. It might be something simple like a database where, again, that microservice controls its own data. But it could be some other service, a stateful service even in its own right. Moreover, when I deploy these services inside a mesh, they might not be using RESTful APIs. very often you'll find that people prefer other formats to do this. And they can because they are both the provider and the consumer of that data at the same time. So it's quite often that you'll see services deployed to the mesh that are using something like gRPC, which is if you guys aren't familiar with that, that's a Google remote procedure call format that uses HTTP2. It's not RESTful. It goes back to using strict formatted formats for its data. It sends it in binary format. So if you're in love with REST like I am, you look at that and you think it's gross and ugly and you hate it. But it does provide some distinct advantages if you need to have direct control over every format on either side. But we need a way to manage all that, right? I need a way to allow the services in a polyglot fashion to deploy in any format they like, to consume the services from one another, that notwithstanding, but still manage that. Throttle them when they're overstepping their bounds, and to keep track at what rate they're doing it so that I can apply quotas, the type of throttling. Or just keep track of when someone's using an older service. Because again, a beehive that has 50,000 bees, at some point those bees die. That's the nice thing about beehives. They die and new ones are reproduced. But in your microservices mesh environment, that's not the case. If you don't have any way to manage those services, they're still running. If you don't have any way to manage the ingress point for those individual services, then they're still active and running. And if you don't have any way to keep track of which of those older services, those services that you so much want to deprecate, are still running, then you're lost and it's chaos. And it's like managing a beehive in the wild. So what the platform play that we're looking for addresses that management of that type of complexity and the management of kind of the between conversations at the API level. And this is what gives us this analytics, rate controls, and security. And what does this mean for Edge versus Mesh APIs? So my case here is that Edge APIs versus Mesh APIs are a little bit different. And they've kind of got different goals. But I would argue that at the end of the day, when you want to provide real value to an external consumer, you're nevertheless going to have to do a mashup of some kind. And as soon as you do that, you return back to this digital value chain. So the impetus behind all this, as I said, originally was that there was this fear that the world that we live and work in and where we deliver value is going to be commoditized. And the thought leadership that we think we've provided for a long time is going away. And in fact, I was the one who brought that up, and much of the chagrin of my fellow employees. But I no longer think so. So I now think that actually we're solving two different types of problems, and we're solving them in different ways. So solving complexity requires biology, and solving the problems of these small particles interactions at universal scales require physics. And likewise, I think solving mesh problems requires something adapted to handle that kind of massive volume of discrete elements. And at the end of the day, when you want to mash them up to something that's uniquely valuable to some kind of developer, you're going to measure the success of your platform based on how well that developer delivers a fantastic user experience to whoever it is on the far left. Thanks.